In this video, we will discuss confidence intervals. A point estimate is a specific numerical value estimate of a parameter. The best point estimate of the population mean mu is the sample mean x bar. Sample measures, statistics, are used to estimate population measures, parameters. These statistics are called estimators. There are three properties of a good estimator. The estimator should be unbiased. The expected value or mean of the estimator of the estimates obtained from samples of a given size is equal to the parameter being estimated. The estimator should be consistent. As sample size increases, the value of the estimator approaches the value of the parameter estimated. The estimator should be relatively efficient. Of all the statistics that can be used to estimate a parameter, the relatively efficient estimator has the smallest variance. An interval estimate is an interval or range of values used to estimate the parameter. This estimate may or may not contain the value of the parameter being estimated. In an interval estimate, the parameter is specified as being between two values. Either the interval contains the parameter or it does not. A degree of confidence, usually a percent, is assigned before the interval estimate is made. Larger confidence ratings require larger intervals. The confidence level of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter, assuming that a large number of samples are selected and the estimation process on the same parameter is repeated. A confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample and by using the specific confidence level of the estimate. Three common confidence intervals are used: the 90%, the 95%, and the 99% confidence intervals. The formula for a confidence interval of the mean for a specific alpha when sigma is known. When alpha is the total area in both tails of the standard normal distribution curve, and z sub alpha over 2 is a critical value, the confidence interval of the mean is given by x bar minus z sub alpha over 2 times sigma divided by the square root of n is less than mu is less than x bar plus z sub alpha over 2 times sigma over the square root of n. For a 90% confidence interval, z sub alpha over 2 is equal to 1.65. For a 95% confidence interval, z sub alpha over 2 is equal to 1.96. And for a 99% confidence interval, z sub alpha over 2 is equal to 2.58. The term z sub alpha over 2 times sigma over the square root of n is called the margin of error. The margin of error, also called the maximum error of the estimate, is the maximum likely difference between the point estimate of a parameter and the actual value of the parameter. Assumptions for finding a confidence interval for a mean when sigma is known. First, the sample is a random sample. And second, either n is greater than or equal to 30, or the population is normally distributed when n is less than 30. Some statistical techniques are called robust, which means that the distribution of the variable can depart somewhat from normality and valid conclusions can still be obtained. The rounding rule for a confidence interval of a mean. When you are computing a confidence interval for a population mean by using raw data, round off to one more decimal place than the number of decimal places in the original data. When you are computing a confidence interval using a sample mean and a standard deviation, round off to the same number of decimal places as given for the mean. Example. A researcher wants to estimate the number of days it takes to sell a Chevrolet Aveo. A random sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation is 60 days. Find the best point estimate of the population mean and the 95% confidence interval. The only estimate we have for the population mean is 54 days, which makes it the best point estimate. For the 95% confidence level, use z equals 1.96. Then x bar minus minus z sub alpha over 2 times sigma over the square root of n is less than mu is less than x bar plus z sub alpha over 2 times sigma over the square root of n. We plug in the numbers. We get 54 minus 1.96 times 6 over the square root of 50 is less than mu is less than 54 plus 1.96 times 6 over the square root of 50. And this comes out to 52.3 is less than mu is less than 55.7. We can say with 95% confidence that the interval between 52.3 and 55.7 days contains the population mean based on a sample of 50 automobiles. And I owned a Chevrolet Aveo, and I'm not surprised by this. Another example. A large urgent care center with 4 doctors found that they can see an average of 18 patients per hour. Assume the standard deviation is 3.2. A random sample of 42 hours was selected. Find the 99% confidence interval of the mean. Solution. The best point estimate of the mean is 18, and we use 2.58 for z sub alpha over 2. When we do this, we do the math. It's pretty simple math. It's the hardest thing in there is a square root. And we get 16.7 is less than mu is less than 19.3. And we're going to round this because we're talking about the number of patients that can be seen in an hour, and we can't see a fractional patient. So we can be 99% confident after rounding that the mean number of patients that the center can care for in 1 hour is between 17 and 19. Finally, we may want to be able to find confidence levels other than 90%, 95%, and 99%. To do this, we must be able to find appropriate values for z sub alpha over 2. So to find the value of z sub alpha over 2, first determine the percent confidence you are seeking and convert it to a decimal, d. Then alpha is equal to 1 minus d, so alpha over 2 is 1 minus d over 2. Then find z sub alpha over 2 in table E on page 779. So for example, if you want to have 98% confidence, convert 98% to 0.98. Then alpha is equal to 1 minus 0.98, which is 0.02. So alpha over 2 is 0.01. Z sub 0.01 is the z value that gives an area of 0.01, which is 2.33.